Hello everyone, this is the WECV 2021 presentation for our paper named RODNet, Radar Object Detection Using Cross-Modal Supervision. I am Yizhou Wang. This work is from the University of Washington and the Silk Wave Holdings Limited. First, let me briefly introduce our problems to address. We focus on the object detection task in autonomous driving applications. However, camera-based object detection is not reliable in some driving scenarios, for example, weak or strong lightning and bad weather. But radar is usually much more robust and cost-efficient. Here are two examples when camera is not reliable. So, can we detect the objects purely from the radar when camera fails? Typically, there are two different kinds of radar data representations. Radar points used in the nuisance dataset is an intuitive representation that shows the 3D locations of the reflected points. However, they are usually very sparse and do not contain speed information. The second kind of representation is radar frequency image, which we are using in this work. It is a frequency map in the range azimuth coordinates. RF image is better than the radar points is because it obtains rich information including object locations, shapes, surface texture, and speed. Since FFT considers all of this information. After the background of the radar data is introduced, another question is how to train the radar object detector. Unlike camera-based object detection, the annotation on the radar data are usually significantly expensive and sometimes impossible to obtain. The following example shows 4 cars in the RGB image, but it is hard to find them in the corresponding RF image. Thus, in this paper, we propose a camera radar cross-modal supervision framework. Our cross-modal supervision framework contains a teacher and a student. Our teacher is a proposed camera radar fused supervision method to provide object annotations during the network training, while our student is the proposed Roundnet that predicts object detection results purely using the radar data as the input. Our teacher named CRF Supervision is trying to generate probability maps representing the existence of the objects. The probability maps fuse the information from both the camera and radar. The camera's information is obtained by our previous work about visual object 3D localization using the Gaussian distributions, while the radar's information is from the radar CFAR detections. Our final annotations are calculated by element-wise multiplication and represented by a set of confidence maps. As for the student Roundnet, its inputs are RF snippets and outputs are the confidence maps. We propose 3 network architectures for our Roundnet: CDC for a 3D convolutional autoencoder, HG for a 3D convolutional stuck hourglass network, HGWI for adding temporal inception for different temporal kernel scales. To train and validate our method, we collect a dataset named CREW, containing synchronized and well-calibrated camera and radar sensor system. It includes about 3 hours at 30 FPS data with 4 different scenarios: parking lot, campus road, city street, and highway. The processed CREW dataset is available at our project website. Here are some experimental results for our Roundnet in different driving scenarios. Our Roundnet works very well even during the night when the camera is not reliable. Comparing with some classical radar object detection method, our Roundnet outperforms by a large margin, about 40% on AP and about 12% on AR. Please check our website for the detailed information, demos, release datasets, source code, and future works. Thanks for listening.